There are a number of people who are looking at, can't we pick up the same signal without putting probes in your brain? As a surgeon, I don't want a probe in my brain. And so perhaps it will be able to do it, but this is a huge, very, very large program because it's so difficult. The signal-to-noise ratio on that is so tiny that it's going to take a lot of work to be able to pick up the same information from outside the skull as they're inside. But there is research going. Although I did notice that for $399, you can get a game controller that follows your eye motion, and theoretically, they tell me, I didn't look at the data on there, that actually picks up some of the signals from your brain and allows you to control a very simple program. This is by Emotive Technologies, $399, and it works on the Xbox. Other areas that we need to be aware of. We can replace any part in the human. We've got intelligent prostheses. As a matter of fact, we're not doing a lot of research in that area because these are so good right now. Some iterative development, but not basic research in that area. Our basic research is focusing on the upper arm. But these are now so good that above the knee amputations, we have our soldiers returning to battle after they have had a replacement and a retraining with an artificial prosthesis, which is off the shelf. We're also growing organs. This is the icon, if you will, of the information age, of bioengineering, if you will, growing new organs. We, as I mentioned, have grown virtually every known organ in the human body except for the brain, every tissue as well. And we're making success. We have 10-year follow-up on the artificially grown bladder from stem cells reimplanted into the patient. Unknown to them, the success on this was much greater than they expected. They harvested the stem cells from the bladder of the patient. They would grow in about 4 weeks a bladder by using a bioresorbable matrix with growth factors, angiogenesis factors, and so forth in there. Put that into a bioresorbable machine and be able to actually grow from the patient's own stem cells a bladder. Then they would remove the old one and put the new one in and not give them any chemo or immunotherapy. The reason is because they were their own cells. They won't reject them because they are recognized itself. At the end of 1 year, 12 of these were still completely functioning. 11 of the 12 had 100% reinnervation, which they did not expect. Apparently, these stem cells are sending out neurotrophic factors, which actually recruit the nerves to grow back into it. And in addition to that, at the end of 2.5 years, all of them were completely innervated and nobody had to stimulate them with external stimulation. And once again, at the end of 10 years, they were perfectly fine. Now, this has some very profound implications. First of all, we may not need transplant surgeons anymore. I mean, I love my transplant surgeons, but their main job, what they do is they prevent rejection. But if you grow artificial organs with the patient's own stem cells, they will not be rejected. The second thing is that right now, I like to do upper GI surgery, gastric surgery. I know 23 different operations to do on the stomach. You know, maybe I'll do a polio for an ulcer, or maybe have an acute bleed and I have to do something, or maybe cancer, I'll do a radical gastrectomy. In the future, what am I going to do? Santi? One operation. If there's anything wrong with your stomach, I'm going to take it out and give you a new one. I mean, but think about this. We in healthcare are the only industry that doesn't do that. Get your car fixed. Nobody fixes anything anymore. They find what's wrong and replace the part or give you a new one. Nobody's fixing anything anymore. So why are we? So, as I mentioned, we can replace virtually any part of your human body except for your brain, and we're getting some incredible new discoveries in nerve regeneration and neuron regeneration as well. And there are even a couple of commercial companies, I'm not affiliated with any of them, that you can send your stem cells to, and they will what's called expand the tissue or grow the organ for you. So this is no longer pie in the sky, and it's even going towards commercialization. Genetic engineering. The orb spider makes the strongest known fiber on this planet. We use it for parachutes and so forth. Nexia Technology here in Montreal discovered the genetic sequence, took it out of the spider, put it into goats, and now has unlimited quantities of the strongest known fiber in the planet in the milk of the goats. They just harvest it right out of there. I mean, what does this mean? Maybe in the future, instead of having bricks and mortars and smokestacks and terrible old factories, what we'll end up having are herds of animals or fields of plants that will actually grow the things that we need. Now, we can't do this for everything, but quite honestly, there are a number of things that we will be able to do to replace the manufacturing process with a renewable manufacturing process by nature itself. I just saw this the other day, hamburger that's artificially grown using stem cells. And as you think about the process that we use today in order to get the meat that we eat and the stockyards and the amount of corn and other things that we have to feed them and so on and so forth, that's an enormous process. It's not really loved by the animals who we eat. So here may be an alternative. There may come a day in the not too distant future, 5, 10, 20 years from now, when we'll be actually growing the meat that we want. It will be to specification. It won't necessarily be whatever that particular type of animal has available at that time. Suspended animation. This is one of my favorites. I visited Brian Barnes up in Alaska. This is the Alaska ground squirrel, and he hibernates. But he hibernates because he turns himself off. And Brian was the one that discovered that animals turn themselves off. There is a place in the hypothalamus that we don't know what the stimulus is yet, but when that stimulus happens, the hypothalamus sends out a massive amount of signaling factors that go to all of the organs in your body. And it lands on the mitochondrial membrane between between NAD, NADH, acetyl coenzyme A, where ADP comes in and gets the oxygen electrons and is actually able to take that over to ATP so we have energy. That's the mechanism of action. And something that they have interferes with it. Mark Roth at the University of Washington Seattle Cancer Center discovered he can do that, if you will, with hydrogen sulfide. And so I went to his lab because he was around the corner. I said, Mark, what are you doing? And he says, oh, I'm just starting an experiment. Why don't you take a look at this? So I went to his lab, and here he had this mouse, and he had just put them underneath a jar, and he was giving him some hydrogen sulfide gas. And in about 5 minutes, it went, and so we were monitoring it. He was dead. He had no heart rate. EKG was flat. He wasn't breathing. EEG had absolutely no evidence of any signals whatsoever. Body temperature became ambient. We did a functional MRI, no brain activity. They met every known criteria of death. I says, well, what are we going to do now? He says, we're going out for lunch. So we went out for lunch, had some fun, saw some of his lab, came back about 4.5, 5 hours later, and he said, okay, time to wake him up. I said, wake him up? He's dead. He said, no, we're going to wake him up. So he took the top off of him, put some oxygen, the mouse woke up. And because he hadn't eaten, and we had, he found the maze, ran through the maze, and started feeding himself. So we know his brain was intact. I said, Mark, what is going on here? And he answered with a question. He says, what is the most energetic thing that you will ever do? Now, I know what you're thinking. Sex, that's a lot of energy, but that's not it. The answer is dying. Just before you die, what you try to do is activate all the alternate pathways, shut down the non-essential ones, and keep your heart, your brain, and your kidneys alive. But that takes enormous amount of energy because these alternate pathways are not as efficient as your usual pathways. But what Mark said was that if you have stopped the flow of energy, if you have blocked it, you can't die. Dying is kind of an auto-digestion process. It requires an enormous amount of energy to die. But if it's been turned off, you can't die. You're not alive, but you can't die. I said, what's going on here? He said, suspended animation? I don't know. We don't know what the answer to this is, but I think this is an extraordinarily fascinating area of research. I like it because I think this could be our next form of anesthesia. Because when they're in this state, I can cut them and they won't bleed. They certainly won't move. And there's no chance whatever that they could possibly feel anything because their brain is turned off.